Hey, time for our next topic in our unit on monomials and polynomials, and we're going to be talking in this lesson about polynomial multiplication. So a couple things that we need to remember, and we're going to put these ideas together. So you'll probably pick up on this really fast because it does involve ideas you've already used. So if I have x to some power times x to another power, product rule tells me that we add those powers. Hopefully, after what else we've done, that is familiar. And then distributive property, we know that when we can't combine what's inside, but something on the outside is touching those parentheses, there is not a sign in between, then we need to multiply the outside times each term inside the parentheses. And so example 1 here, this is what I'm thinking, x times x, and remember they each have 1s, so that is x squared, and then I'm thinking x, so plus, right, times 4, and of course it just looks a lot better to write that as 4x, not x4, so plus 4x. You'll often see me do this, x times x, and write down x squared, x times the 4, and write down 4x. Sometimes I'll refer to those as my rainbows. Or I might say, I've had students say, okay, I'm just going to rainbow this out now, right? And if that's what helps them remember the process, yes, we are distributing though, and using product rule. So still the same policy remains that coefficients don't behave like exponents. So here, when I do the 5m cubed times 3m squared, I get 15m to the 5th. So the 5 and the 3 did multiply, but the exponents added. Then let's move on over to the middle term. 5m cubed times negative m would be negative 5m to the 4th. If you're forgetting about that extra power, slide a little 1 on there before you ever get started. And then that last term, you can multiply, even though the other one doesn't have a variable. You just multiply those coefficients, so negative 35, and it still has the same m to the 3rd power that the outside factor had. Notice that if what's inside your parenthesis is nice and orderly in standard form, second power, first power, 0 power, in other words, no variable, these answers are also going to be nice and in order, 5, 4, 3, as far as the exponents. Okay, so if you want to try some of the next section before I work a few of them, go ahead and pause and you can try that. But I'll work through a few more of these, not all of them, but a few more. Don't forget that k times k, any variable times itself, is going to give you that variable squared, and then k times negative 9, negative 9k. Just like in distributive property before, be careful with your signs. So negative 6p to the 5th, but then negative times negative, positive 48p. They can be longer, as we have the second example up top. Let's jump down to number 8. So remember, I'm starting here and then just go left to right. So negative 2 times 6 is negative 12. Add the exponents. 4 plus 2 is 6. Negative 2 times negative 12 is positive 24. Add the exponents, x to the 5th. Negative 2 times 18, negative 36. Add the exponents. Well, 18 doesn't have any, but you still have the x to the 4th. from the outside factor. And notice how it's nice and orderly, 6th power, 5th power, 4th power, nice and smooth. As far as being in standard form, if there's only one variable, yes, I expect that to be in standard form. If there are 2 variables, you can leave it in whatever order. I think most of these are, if not all of these, are already in standard form. With 2 variables, sometimes they're put in order by the total degree of each term, and sometimes they're put in order by the highest power of the first variable. So sometimes there's a little disagreement on which way, or it may depend on what you're doing. So for instance, number 9 then would be p to the 7th, q to the 5th, so I added my p's, I added my q's, minus p to the 3rd, q to the 4th. And again, the directions say in standard form, but all these that I worked through were already in standard form, so they were fine just in the order that they were given. Okay, try a few more of those. Alright, before I move on, I filled in a few more of those answers. The ones in red were not there before, so if you tried a few more, you could check those solutions. Those products, I guess I should say. Alright, I'm going to move along now. Notice when there are 2 variables, you do not have to have like terms to be able to multiply. In fact, you can multiply even if one of them doesn't have that variable at all. So I'm going to look at 13 and 14 just as a couple examples. So for number 13, I'm going to start, of course, with this. So I'm doing -7 times 9, then my c, and then 3 plus 2, then my d, 2 plus 2. Now I'm going to move on and take that outside factor times the second term. 2 negatives when I multiply give me a positive, so that's 28. This guy counts as 1, so c to the 4th, and d to the 2 plus 5 is 7. So again, what's going on, just in case you're still not catching what I'm saying, I'm doing -7 times 9, then I'm doing c to the 3 plus 2, d to the 2 plus 2. Then I'm moving on, -7 times -4, new term. They're not all being multiplied. It would be a different problem had there been a parenthesis here. Different problem. Then it would all be multiplication, all in one big smush. And then I did -7 times -4, which you could just put plus to start with, and then c to the 3rd plus 1, and d to the 2 plus 5. I would not expect to see you write that down a lot, but just in case it's helpful to see one where I've made a few more notes. 14 is one where the second term doesn't have any m's, but we can still multiply. So 10 times -2, -20, m 4 plus 1 is 5, n 1 plus 3 is 4. Then move on, 10 times 3 is 30, m stays 4th power, and then n becomes 2nd power for 1 plus 1. So we're not adding anything to the m's, but we are adding something to the n's. And then the last ones here on this page, we are distributing, so we're multiplying, but there is like 2 parts to multiply in like number 16, so we're going to distribute and then combine like terms. We've done some things like this before, they just didn't have, powers in them. so it should not seem completely foreign. Negative 35w to the second plus 15w from the 3 times 5. And then over here, new set of distributing. Negative 26w plus 18w to the third. And now here's one that we do need to move around to put it in standard form. So standard form, the one who has the highest power goes first. So 18w to the third minus 35w squared. And then these two are like terms, so they can get together. Okay, I hope that has been helpful so far. On the next page, you just have more of the same. I'm going to go down to these geometric applications. So the geometric applications on the next page. So the area of a trapezoid, okay, we talked about this before. We have to add the two bases together, that's the top and bottom, the two parallel sides, divide that by 2, and multiply times the height. Alright, so here, my two bases, this and this. So I need to add those together. So I'm just combining like terms. So I've got my 2x cubed plus 8x squared, and then 3x and negative x plus 2x. All that's going to get divided by 2, and then that dotted line inside, that's my height. And you can treat this like it's a big parenthesis, alright? So, because everything in there is going to get multiplied by that 4x squared. So this is going to become x cubed plus 4x squared plus 2x. And then we're going to have to distribute the 4x squared times that. So 4x to the 5th plus 16x to the 4th plus 8x to the 3rd. All of that, square units, would be the area of that trapezoid. The next one about the shaded region, I love this kind of problem because we have to see two different things. We don't have direct measurements for like how long different parts of this are. So what we can do, and maybe you already have figured this out, is we can find the large rectangle and the small rectangle and then subtract them. I need to scroll down, so hopefully you have everything you need from the first part. So I could not see the bottom of the page. Alright, so again, my strategy here is going to be to take the large rectangle, subtract the small rectangle. So on the subtraction step, I'm just combining like terms at that point. So for that large rectangle, length times width, doesn't matter which one I write first. I'm going to go ahead and put the 6x on the outside on the left, but I'm multiplying these two to get my area of the large one. And then I'll need to multiply these two to get my area for the small one. So 2x times 5x plus 3. So then I distribute, because area is multiplication, so this becomes 48x squared minus 6x. And the second one becomes negative, I'm going to go ahead and carry that through, negative 10x squared minus 6x. You could just find the area, but then subtract, but you'd have to be sure then that you distribute the negative sign. So I find it easier to just go ahead and write it this way, and then distribute that negative as I find the area. So now when I do this, now I need to put my like terms together. So I have 38x squared and negative 12x. That would be the area of the shaded part. Okay, that should help you be prepared for that next homework, which is on page 21 and no, just 21. Alright, so next homework on page 21, at least as it's currently numbered, and that's homework 7.